When Stack Audio announced their network filter at a price of £200 excluding tax, my immediate reaction was, that's a great price. Let's see if it works as good as their other products. Up till now I have reviewed Stack Audio's network player, loudspeaker isolators and equipment isolators, and they all performed very good to extremely good. So the expectations were high. But before we dive into it, let's first see where it fits into your stereo. The SmoothLAN is designed to clean up the network signal for network connected audio devices like streamers, network bridges and the like. There are standalone streamers, network players if you like, with or without digital to analog converters, DAC for short, built in, and there are even ones with DAC and amplifiers built in. There are also multi-channel AV receivers that have DACs and multi-channel amplification built in. In this example I use a streamer with built-in DAC connected over analog connections to an amplifier. But the streamer and amplifier combination could easily be replaced by an amplifier with built-in streamer or an AV receiver. Whatever you use has to be connected to a pair of loudspeakers. On the other side of the streamer there of course needs to be a connection to your router over either Wi-Fi or network cable to get access to the internet music services and internet radio stations. The SmoothLAN only works with network cable. You might also have a computer holding music that is connected to the network. If you have a music server running on that computer, like DLA, LMS, Roon or the like, or if you use a self-indexing streamer like those by Sonos or Bluesound, you will use a Wi-Fi connected smartphone or tablet for control. According to Stack Audio, the SmoothLAN will most likely improve the sound quality best when inserted between the router and the streamer, closest to the streamer. If you use a switch in between your router and the streamer, the SmoothLAN most likely still performs best closest to the streamer. But since there are many ways to set up a network and there are many streamers on the market, you could try other places to insert the SmoothLAN or even use more than one. The SmoothLAN is available in blank and black aluminium. The case measures 104 by 40 by 21.5 mm and weighs 200 grams. It has an RJ45 network connector on both ends and is not directional. The box it came in also holds a 25 cm oxygen-free copper Cat7 Ethernet cable. I didn't try to open the case, but there is an exploded view on their website. It shows that the SmoothLAN is a machine block of aluminium with several pockets that shield the individual components from each other and from influence from outside the SmoothLAN. To assure this, the bottom is tightly screwed against the case using 20 screws. Inside the pocket, EMI absorbing material reduces eventual noise reflections. It's an approach that clearly differs from other manufacturers and the years will tell whether it works. But let's first see why audio grade switches and Ethernet filters can improve the sound quality. For many network specialists will tell you it's pure nonsense. For me it all started with hearing reduced jitter when an audio grade switch was applied. That was the AccuVox AccuSwitch Special Edition. Already in the 80s I heard the effect of jitter on the sound quality after connecting a CD player digitally to an amp with built-in DAC. Poor stereo image, harsh mid-range, restricted deep lows, lacking texture and overall low resolution. Digital equipment might suffer from one or more of them to some degree. They are a result of a less accurate digital to analog conversion. In particular, the precise timing of the rendering of each 44,100 samples per second is essential. Over the last 10 years, brain research has led to the understanding that our auditory system has far higher time resolution than can be concluded from the 20,000 Hz as highest frequency humans can hear. And to avoid that some are going to say, I told you so, we need more bandwidth. Let me once again make clear that the Nyquist theorem clearly proves that 44,100 samples per second give us perfect reconstruction of any waveform up to 22.05 kHz, also in time. But that's theory. Implementing it in the real world isn't that easy, although some true high-end equipment today can come rather close. Another time problem can be caused by the reconstruction filter that is needed on playback. Filters with a close to perfect time behavior are also very hard to build and then only at very high cost. A practical solution for affordable digital equipment might have been MQA, as I have said more often. Although the reconstruction filter problem is not going to be solved by devices like the SmoothLAN Ethernet filter, it can reduce the timing problem during conversion, which can greatly benefit the sound quality. Since I recognize jitter signatures when doing a listening test between standard network switches and audio-grade network switches, I thought for a long time that it was due to better clock oscillators in the audio-grade types. Then Optone Audio came with their ether regen switch that combined a better clock with galvanic separation and regeneration. Together with the UltraCap's power supply it costed about €1,250 including VAT. It was all explained by designer John Swenson in his paper Understanding how perturbations on digital signals can affect the sound quality without changing bits, and how these issues are addressed by the Optone Ether Regen. A few years later, Network Acoustics came with their Eno filter system, costing around €885. By the way, all prices I mention in this video are including 21% VAT, the European sales tax. The Eno was followed up by the Muon and later on by the Muon Pro, the latter costing about €1,890. So you can understand my curiosity when Stack Audio introduced the filter at around €285. You want to know more about the influence of switches and Ethernet filters, watch my video The BS about network switches and the like. Links at the usual places. But I'll give you the short version here. An Ethernet signal, or rather any so-called digital signal, is in fact an analog signal. It's a square wave that can easily be distorted by noise, ground loops, impedance mismatching and the like. A distorted square wave signal causes varying timing during the digital to analog conversion. Where in the ICT world timing is far less critical, and since Ethernet is designed for the ICT world only, this causes no problems there. In audio, with its picosecond critical conversion, it can, and often will, cause severe sound degradation. Filtering the analog square wave signal lowers the pollution/distortion and makes the timing during digital to analog conversion more precise. But you can buffer the signal in the DAC is a question that is often asked. Yes, and if it's done perfectly, you don't need a filter or audio-grade switch. The problem is, it almost never is. To perfectly buffer the signal, you need very fast flip-flops, preferably symmetrical ones, that are powered by a very fast power supply, and so on. See Swenson's paper. I know of only 2 network players, of which the sound quality almost doesn't improve when using the Muon Pro filter, and that are the 2 Grimm audio players. Other filters and switches have no effect on them. If you know a third player that does that, please let me know. Which means you most likely will improve the sound quality using a good Ethernet filter. I started off testing in my Setup 3, where the Win Pro Plus now functions as a streamer, powered from an iFi iPower 2. It was connected to the NAD C361BE amplifier that drove the DALI Oberon 1 loudspeakers. A REL T5 subwoofer was connected to the loudspeaker terminals of the NAD using the REL supplied cable. The switch was a simple €30 TP-Link using a standard power supply that was connected to the central switch on the 3rd floor over a Cat6 cable. The connection to the WIM was also over a normal Cat6 patch cable. The comparison with the SmoothLAN was made by inserting it here just before the beam using the cable that came with the SmoothLAN. The SmoothLAN only gave a small improvement, especially on voices, mainly on sibilants. The sound was also a tad more relaxed, but my advice would be to spend the €285 on a higher quality streamer or a DAC. For the second test I used the Bluesound Node 2 with PD Creative power supply. The amplifier was the brand's PM KI Pearl Lite connected to the node over Celtec London RCA cables. It drove the Acoustic Energy Radiance 1 loudspeakers connected over Kimber 4PR loudspeaker cable. They were supported with a REL T5 subwoofer that was connected to the loudspeaker terminals on the branch using the cable that came with the sub. The switch was the same domestic quality TP-Link that was connected to the central switch on the third floor over a Cat6 patch cable. The connection to the node was also over a Cat6 patch cable. The comparison with the SmoothLAN was made by inserting it here just before the node using the cable that came with the SmoothLAN. Here the SmoothLAN improved the stereo image a bit, while sibilants also improved. And again the sound had a slightly less stress. Overall I would say that buying a SmoothLAN when you already have the node might be interesting, slightly depending on your other equipment and network pollution. Now I use the Eversolo DPM A6 Master Edition with B-Technic linear power supply. It looks identical to the standard DMP A6 apart from this shield. The Master Edition is already a clear step better. Then the added B-Technic LPS A6 linear power supply again adds to that. See the description below this video in YouTube for the reviews. This gem was connected to the Air AX520 amplifier that drove the PMC FAC12 signature loudspeakers on Stack Audio OVA 70 isolators and was connected over AudioQuest Robinhood Zero loudspeaker cable. The network connection came from the Zitzel GS1900-10 HP that was connected to the central switch on the third floor over fiber. The connection on the Eversolo was over a Cat6 patch cable. The comparison with the SmoothLAN again was made by inserting it here just before the Eversolo. Here the effect of filtering was a bit more clear. There was an improvement in the mid-range. Lows had more texture and sibilance control was better. Having said that, it was no comparison to the Network Acoustics first gen Eno network filtering. Which isn't strange given the huge price difference. I mentioned it here again since there are people that think a filter is a filter and they consider themselves smarter than the rest of the world by thinking they have paid less for the same. There are simple galvanic separators on the market that do just that. Just 4 small high frequency transformers in a small package. But proper Ethernet gear, even the cheapest switch, should already have transformers built in, usually integrated in the RJ45 sockets. Filters like the SmoothLAN and others try to filter out noise on the analog square waves that aren't blocked by the galvanic separation. Perhaps some reshaping is done too. Amongst these, SmoothLAN is attractively priced. It's very nicely built and can improve the sound quality to some degree. And on that bombshell we come to the end of this video. As usual, there will be a new video next Friday at 5 PM Central European Time. If you don't want to miss that, subscribe to my channel or follow me on Facebook, Instagram or LinkedIn so you will be informed when new videos are out. Help me reach even more people by giving this video a thumb up or link to this video on the social media. It is much appreciated. Many thanks to those viewers that support this channel financially. It keeps me independent and lets me improve the channel further. If that makes you feel like supporting my work too, the links are in the comments below this video on YouTube. I'm Hans Beekhuyzen, thank you for watching and see you next week. Whatever you do, enjoy the music.